Hello, everyone. I hope that I'm audible. Uh, can please someone confirm that I'm audible and you can hear me? And we can begin with our meetup. Thank you so much. I see the activity in the chat. Hello, everyone, again, and welcome to our data analytics meetup. My name is Evgeny Akulov, and I will be your host tonight. And before we dive in, let's break the ice a little. I want to ask you to share a bit of personal information about y'all. Where are you joining us from today? Please drop your city or country in the Zoom chat. You can drop the flags or you can drop the name. Let's see how far and wide our analytics community stretches, how our geography for today looks like. Uh, yeah, I see we have folks from US, Cyprus, New York City is here, Germany, Spain, Uzbekistan. Okay, let's wait for 1 more minute with that. You can share your geo with us. Okay, nice. Tbilisi, Dallas, Limassol again, India. Never seen anything like that. Very nice. I think we've got people from Limassol, Tbilisi, Berlin, Lisbon, and many more. I really love that this meetup is bringing together folks from all over the world. So thanks for taking the time to be here with us, wherever in the world you are. I do think that we can proceed with an event. So this event is brought to you by Muse Group, the team behind Ultimate Guitar, MuseScore, Audacity, and more. Muse creates the world's most popular content, apps, and platforms for playing, recording, and composing music. You might have heard about one of Muse products. The most well-known probably are Ultimate Guitar, the online catalog of over 2 million tabs and chords for guitar, piano, and more. We have MuseScore, the online sheet music ecosystem, including a catalog of scores at MuseScore.com, MuseScore mobile app, and MuseScore Studio. That's a desktop app for music composition, and Audacity, online free app for recording and editing audio. The Muse community across all products now exceeds 400 million people with such a diverse and global user base. And analytics actually plays a crucial role in understanding different needs and driving better product decisions. And that is why we are here, to share our experience and to welcome expertise from our colleagues from other companies. And we are actually very thrilled to have you with us tonight. And tonight we have three fantastic speakers. We'll share tools, real world cases, and frameworks they use to make better product decisions through analytics. Whether you are building experiments, evolving your platforms, or analyzing long-term impact, this session is for you. So a bit of content about the rules. Here's how the event will go. Each speaker has 20 or 25 minutes for their talk. And then after your virtual applause, virtual claps, you can do them in the Zoom, we will have 5 minutes for questions you are able to drop in the chat. It would be also great if you will be able to turn on your cameras. It is always better to see some friendly faces and create this atmosphere of offline real networking. And to help you feel more relaxed, our team at Muse has prepared some virtual backgrounds you are welcome to use. We will drop them for you in a minute. So if you do not really have a very good background, you can use ours and it will be okay. So you can join us with the camera. Yeah, I do think you can find them in the chat. Yeah, I see the link to the Google Drive. You can download the backgrounds and turn them on and turn your cameras on to support our speakers as well. And with all that in mind, I do think that we are ready to welcome our first speaker. And as a first speaker today, we are going to have Nikolai Romanenkov, head of machine learning at Muse Group. He'll share the journey of building and evolving their internal A/B testing tools from early stage ideas to a mature experimentation platform. Nikolai, let's confirm that you are audible. Are you here with us?
Yeah, I'm here. Hi, everyone.
Yeah, I think we can hear Nikolai. That is good. So I would like y'all to give virtual applause for Nikolai. Nikolai, the floor is yours.
Super amazing. So let me share my presentation. Just small preparation. And I think I'm ready to start. Yes, super. So hi, everyone again. And Evgeny, thank you for such a warm introduction. Today, I want to tell you a little bit about our AB processes at Muse. And it's not about, so this presentation, it's not about how cool we are, so and here our case, how we build it. No, it's more about our way, our pain. And to be honest, if we had known this 2 years ago, we would have saved a lot of time, a lot of energy, a lot of nerves, and what's more important, a lot of money. And a little bit about myself. So yeah, my name is Nikolai. I'm head of ML, but previously I worked as a ML engineer, and sometimes at some point I help our product teams with data analysis, and I could say that I worked part-time data analyst as well. And if you have or if you will have any questions related to this presentation or any other questions, please feel free to reach me on LinkedIn or via email. So a little bit about us. Evgeny already told you huge information about us, but to sum up, we are more than 50 online and offline products, and the biggest one is Ultimate Guitar and MuseScore for our online distribution, and Hal Leonard, one of the biggest printed musician books distributor. Our DAO is more than 2.5 million users, and we work with more than 100 gigabyte data daily. And our data team is quite big. We have 25 amazing people, such as data analysts, data engineers, analytics engineers, and machine learning engineers. And today I would like to start from the topic that we are data-driven. And it's not just a word, it's not our opinion, it's our way to live, our way to think. Because every our project is not just a project and we don't do something to do. We have hypotheses which have a clear goal, so we know what we do. We understand what we expect from our initiatives, what we want to grow or what we want to get from our initiatives. We design our experiment and we would like to know how to do it clearly because we don't want to see something that we want to see a real data. And also all our experiments has a clear definition of done and clear summary what was done and what we got from our experiment. As a result, with good processes at our company, every analyst conduct more than 2 experiments per week. Because yeah, we have a quite clear processes with A/B testing, and they can spend more time for ad hoc analytics and for researches. But we are data-driven not because we want to be data-driven. We are data-driven because it's necessary for us. We used to be a self-funded team. As a result, every decision impacted and still impacts on our survival. We cannot launch low quality feature because it risks to us turn into a junkyard. And as a result, every experiment and initiatives must bring clear and measurable value for us. But at the beginning, we were a small team, just Ultimate Guitar with one data analyst. We had less than 100 events And so, as you can expect, when you have one data analyst, all processes with data analytics is quite clear, because he or she do whatever he or she want. And we used to and we have used external analytics tools such as Yandex.Metrica and Google Analytics, and it was more than enough. But then we start to grow and we acquired other products. And as a result of collaboration between different teams during the requirements, our analysts, our other specialists built an AB platform which highlighted only significant changes. We had splitter with buckets. We calculated some basic statistics, but still every analyst had their own tools. And maybe you can think that that's enough, guys, you're already somehow data-driven, but no, we got some problems. First of all, it's a small joke, but still, it can explain our pain. Our analysts weren't in some, like horizontal of analytics. So we didn't collaborate. And as a result, for example, I, as an engineer, came and asked, okay, guys, I want to roll out some feature, ML feature, and I need your support with metrics. And one analyst from one team said to me, okay, you have significant changes because I see, like, for example, a t-test, and it's quite good, you grow some metrics. But another one said, no, because my u-test shows that no, you have nothing. And that's a problem, because we don't have some processes at our company. The second problem, we had no standardization of metrics, and as a result, everyone calculated their own in their own way and looks for what they want. Another problem, we didn't analyze results. We didn't watch the guardrail, and we rolled according to one metric. Another one, we saw, especially our stakeholders, they saw there is an impact, but it doesn't matter that it's a random metrics or prints. For example, we had a lot of cases when they said, okay, we grow somehow something, let's roll out it. And the last one, but of course it's not the last one, it's one of the most important one. When I came, I had a result from data analyst. He's like calculation processes, calculator. Another one from our AB platform, which shows significant changes. And the third one, which I had in a Confluence page with results. And so what is true? And as a result, we came to point that data must drive decision, not desire them. And of course, we had a problem. We had to fix it. First of all, what we need to create the single source of truth and the single source of decision making for everyone. Okay, what we need for that? So our key requirements. First of all, we run a lot of experiments and growth. So as a result, scalability is essential for us. The second one, platform must support long-running tests and be able to calculate huge amount of data. Another one, we have to support custom filters and segmentation for different teams, because sometimes we can't just look at metrics in overall. We need to focus on essential. And the last one, we have to have one source of truth. So from the house to clarity, we came to OLAP, one single source of truth. It's not rocket science, but it's very important to build a very strong foundation. When you have one single source of truth for all your metrics, it's much easier to build over it something that everyone will trust. So how it still looks, so it's the same as we had. So we have event stream, we have all necessary dimensions like users, every date, we have for every users by every dimension like platform and etc. Metrics and how our user interact with our products. So what we got from OLAP and what we gained. First of all, raw data could not be aggregated due to high load. So I mean, when you have a lot of information when we have a lot of information inside of our database, it was quite difficult to work with it and to aggregate it. We spent a lot of time and a lot of resources to it. And OLAP is already pre-aggregated data. So as a result, you just need to drop some not necessary dimensions for you right now and group it. And actually, we have also quite pretty present from OLAP. We have an easy, clean, and always up-to-date dashboards because we build them on the top of OLAP. But still, we keep core functional from our AB platform and from so everything that our analysts calculate. T-test for averages, he square for amount of unique users, and we calculate it daily. So, and actually, I wish I could stop here and said that was more than enough. We have a new AB platform and we are really cool. We are happy with it. But actually, I can't say that. I'm really sorry. And now it actually the most important part. First of all, why, what's happened and what went wrong? Our experiments failed due to high load. Total time for calculations was more than 10 hours per day, and the computation consumed nearly all available big data cluster resources. So we got every day via Slack logs that something went wrong, we cannot calculate, and it was quite, we were not happy with it. Another problem is that still we didn't cover all necessity of other teams, of other data analysts member. And the last one, but really important, we didn't get trust from our analysts and product owners. So sometimes they said, okay, guys, it's a AB platform, it's one single source of truth, but still I see the difference between your numbers and mine, and where's the truth? What was the reason of this problem? And it's actually a simple one. We, at our Muse team, we have a core analytics team, and this team implemented it based on their vision of best practices. So of course, we asked other team members of other products what you need, but we try to roll out our vision, so how it should work. So, okay, let's fix our mistakes. So we decided to select only necessary metrics, and as a result, we built a system of metrics with clear metrics which are really important and which has impact on our decision-making process. Another one, we made our platform more functional, and we got a reference from a Lego. So we would like to keep it simple, and everyone can put additional code inside the platform without any changes in core functionality, and you don't have to change everything, just put it inside. And of course, we have to optimize code and speed it up. So how our calculation looks and looked and looks now. we designed our A/B testing framework as a modular constructor, and it's making easy to plug in new functionality. And also we decided to use a Spark for parallel calculation and also to optimize memory usage of inside of our big data cluster. Also, when we have a lot of experiments, as I said, every analyst conduct more than 2 per week, we really need an prioritization for our experiment. The first priority is for newly launched experiments, which was launched 1 day before, just to health check. So is it okay, how it looks, and etc. That we didn't break, we didn't have a bug inside of our experiment. The next priority is for experiments that are about to end at lasted less than 2 weeks. Because they're small enough to calculate as fast as possible. And the last priority for heavy computation experiments, so they was launched for more than 2 weeks, and sometimes they need a huge amount of resources, and they postponed to a night. Also, why not? Why we cannot implement some cool things like reduce variance, like cupids and cupax? So it helps us to reduce variance and as a result to have more significant changes faster. Also, we implemented additional functional for rate metrics. And as a result, our calculation process looks like on the screen. So it's functional code where we calculate rate metrics in one way, uniques another way, averages we can use a cupids or just the test. All of it inside of Spark. We put it in our ClickHouse storage, and we have an amazing dashboard for A/B metrics. The whole process, as a result, looks like on the screen. So we have a data flow when we collect data from backend by streaming via Kafka. We put it inside of ClickHouse by raw data, like raw data, and then via Airflow we make a backup of raw data and put it inside of Hadoop. Then every day we trigger our ALAP calculation and aggregate our data, put it inside of Hadoop, and make a copy of our ALAP to ClickHouse. Over the ALAP, we have a monitoring, which we can see at Slack, and also ALAP we use in our Redash for ad hoc analysis and for product dashboards at Metabase. And as I said, for calculation, we have a trigger which launch in some priority our processes, and we have a summary of experiments at our Slack channels. But still, we have a problem, and the biggest one is adoption. Because it was quite a big, so we have been working for our AB platform more than 2 years, and many analysts prefer their familiar tools despite the new system capabilities. And actually, our data analysts are expected to drive changes with their domains, but this doesn't always happen in practice. So sometimes they ignore us, or I mean, not ignore us, but still it's difficult when you give them something and say, use it. No, they want to participate in your development, and so that's what we expected from our analysts. And because it was a huge time frame for our development, different teams adopted their own logic. For example, someone calculated for users not only from a lab but from our CRM tools. Someone for example, added a dynamic metrics check, and another implemented separation mismatch detection. So how to fix this main problem? So we need to merge multiple analyst-specific setups into a single cohesive system. So that's our next step. That's what we do right now. We have to leverage our unified metric system and refactor all up, removing unnecessary metrics and removing unnecessary dimension. And we keep an eye on industry trends and adopt them to our platform. And yeah, but still we're moving forward. We want to be smarter and we want a more scalable experimentation ecosystem. So as a result, what lessons we learned from this and what could help us to save a lot of time? So first of all, please involve analysts from the start to ensure real adoption and feedback loops. They want to participate in it. Avoid over-engineering. Do not calculate as much as possible by default, because otherwise you will have a lot of alerts. Focus on what's really necessary and what's actually used. Focus on what's and create a shared consistent loyal for all the team. I mean, a system of metrics. It really helps you to understand what is necessary for you. So that's it. That's quite it from my side, and I will be glad to answer on any of your questions.
I can do my claps. Actually, thank you so much, Nikolai, for this wonderful speech. We really encourage you to drop your questions to the chat. I do think that we have 5-7 minutes to answer all of them. And yeah, of course, give virtual applause for the Nikolai who break the ice for other speakers as well. I do think that it is a wonderful performance from Nikolai. Do we have any questions in the chat? Yeah, I do think that we have one. Can you show some practical, sir? That is the question. Can you show some practical, Nikolai? Do you understand the question, or we need to ask
can you elaborate it a little bit? Yeah.
Okay, yeah. If you will elaborate, it would be good. We have 2 more questions. First one, do you have any open positions? Someone is ready to work with you, I think.
Yes, so feel free to come to our website, mue.se, or you can reach me for a refer as well. Yeah, we have an open position for, I think, analytics engineer and also for node data team as well.
Okay, that's an interesting follow-up, I think, from your performance. We have one more question from Vitaly. How did 2 weeks prove to be enough for product tests?
Okay, so not always 2 weeks. We actually have a MD calculator, minimal data effect calculator. So, and based on statistics, we understand how long we should launch our experiment. For example, for our product team, especially for like, okay, for our core functional with tabs, sometimes 1 week is more than enough because we have a huge traffic on this place. But for example, for our monetization team, we have quite longer, like sometimes even months or more for significant changes, because we have more or less traffic than on our main website or our main app.
Okay. I think we have 2 more questions. I think we have 3 more questions. Let's pick a couple of them. Okay, I do think that we have time for 2 of them at least. So the first question is from Michael. Could you walk us through something you tested briefly? Could you walk us through something you tested? So maybe it's about the actual examples again.
Okay, yeah, I can share some experience with this AB platform, and actually that's the point where I struggled with the previous one, and the point when we started to fix our previous AB platform. So when I started to be, so when I joined Muse, I was an ML engineer and I worked with a recommendation on our main website. So like what to play next. So the simple one. And I built a recommendation algorithm which like generated, I don't remember, like 16 next items which users are going to play. And we tested it against our top at the country or top in total, in overall, I mean. And at that point, I calculated in through a Python notebook, which I got from our data analyst, which had quit just before I started to conduct this A/B test. And I also got a result from this automated A/B platform, which highlighted me that yeah, I get significant changes at some point in applications, but my code was for a website, so I think you understand that it's randomly it's random changes. So because of course p-value 5%, 5% of changes we can see. Yeah, and then I calculated it, so I grow in a total how many users used this recommendation block for you, and in total I grows how many items our users view in average.
Okay, thank you so much. And I think we have time for the last question. The last question I will take from Ray. The question from Ray is about the reason why you have 2-week intervals in your experiments. Uh, do you have them because of the agile sprints logic, or there is another reason why you have 2 weeks intervals?
Okay, I think I get a mismatch here. So as I said, yeah, of course, we calculated using MDA calculator. So it's not just some number, 2 weeks, because of our agile sprints or whatever. But for our AB platform, for prioritization, it's really important because after 2 weeks, you already have a lot of data. I mean, like 2.5, okay, more than 100 per day. For 2 weeks, it's already 1.5 terabyte of data. And it's quite difficult to calculate it. Really, sometimes you need a full resource availability. And as a result, it can impact on my work and our data analyst work, because I use big data cluster for my machine learning models, and other data analysts use it for ad hoc researches, for some their code and etc. So that's why we postponed all experiments that more than 2 weeks tonight. So it's not just how long we conduct our experiment. It's a threshold when we understand it's big enough or it's a small experiment. So that's just it.
Okay. Thank you so much, Nikolai. I see the request of sending the presentation for the participants. I think it's a good sign, and I see lots of thanks in the chat. So, Nikolai, thank you so much for your participation.
Yeah, thank you so much.
And I think,
thank you.
yeah, thank you so much. And I think that we can welcome our second speaker because we have just started. And our next speaker is Ksenia Nesterova, Senior Data Analyst at Playrix. And she will explore the dangers of focusing only on short-term A/B test results and why long-term thinking can lead to way better product decisions. Ksenia, take it away. Let's confirm that we can see you and hear you. For now, I cannot see you, but maybe we can hear you. Let's check it out.
Hey, hello, everyone. I do have that he.
Yeah, Can you please confirm that you can hear Ksenia on your from your laptops? Little quiet. Yes. Okay. Good. Maybe a bit louder would be good, but I can hear you perfectly. So yeah, that's good that we confirm that you are audible. The floor is yours. Give some virtual claps for Ksenia. Let's proceed to the second talk.
Yeah, perfect. Thanks for such a warm welcome once again. I will try to talk a bit louder. So, I'm Ksenia. I'm a senior data analyst at Playrix, and today I will try to walk you through why long-term thinking in A/B testing really matters. Like, to start with, I come from the game dev world, but so most of the illustrations and examples will come from there, but trust me, that applies to all businesses, I would say. And to prove that, let's think of really common examples. I believe that a lot of industries are doing onboarding, right? And so the classic situation, you're speeding up onboarding, simplifying or something else, just making it better. In short term, what are you having? You're having more activations, more signups. It's nice. But in long term, it reveals that some users don't really understand the product. So the retention usually drops and LTV suffers. And for example, it leads to the situation that your marketing team can't adjust fast enough for that change. Or like another really common example, I think everybody had that, aggressive push notifications, more frequent or more clickbaiting. In short term, you're having more clicks, more traffic, and it was our main goal. But in long term, it leads us to opt-outs, brand fatigue, and retention drops. Happens? I think yes. So today I will try to explore this A/B testing problem and like some ways out of it in a, I do hope, easy and slightly meme-infused way. So, first of all, let's talk about one of the classic tensions in like any data-driven companies, business versus analysts. On the left side, you got the business team. They want fast, visible revenue impact. Logical? Mm-hmm. Meanwhile, on the analyst side, we're here exploring a lot of metrics and dashboards per test, thinking, okay, but is it significant? Is it really sustainable? What's the trade-off of this change? And often we are seeing non-binary signals, no clear yes or no answers, and this is a misalignment. Business wants confidence in clarity. Analysts bring complexity and lots of information. And unless we close that gap, we risk either delivering the feature too early or getting stuck in endless analytics mode. So it leads us to the impatience problem. When business wants fast wins and analysts feels pressure to show answers quickly, it usually doesn't end well for anyone. What could happen? To begin with, the initial excitement. The test just launched, numbers are up. However, like everyone's celebrating already. But does, for example, 5% revenue growth in 5 days mean that we are totally winning? I'm not sure. Then it comes to premature peaking. Thanks to automatization, everyone could could get access to the dashboards, and they're refreshing them 10 times a day or even more, trying to guess the ending halfway through the movie. But in real world, we have some twists and turns. Are you agree? I think yes. The next one, p-hacking pitfall. Someone finds something statistically significant now and it's an insight by slicing or filtering, even if the real data is nowhere near stable. Has it ever happened to you? I believe for analysts, the answer would be yes. And the last one, wow effect. The test looks amazing at first, but give it a couple of weeks and the shine fades, and sometimes it even reverses. So yeah, impatience is really dangerous in A/B testing. So Let's move on the case study part. We've got a super high potential A/B test. It's kind of big deal for the company. So we're set it up to run for a while, about month and a half. It's a lot. Sounds reasonable, right? Because it's a huge change in their user flow. Our North Star metric, average revenue per user, revenue based, of course. What else would it be? The feature itself, it changes the player's schedule, mainly its frequency, and adds some dynamic to the product. And what is the best part? We've got full support from the entire product team, so the stakes are high. What could go wrong in this situation? Oops, sorry. Finally, the experiment goes live and everything looks great. Like monetization is up, player engagement is stronger than ever, statistically significant uplift from the beginning because we haven't expected such a huge MDA. From analytics perspective, we just want to double check, as we always do. Product manager is in cloud 9. The business is ready to roll out it to production. Looks like a happy, confident test, isn't it? But we committed for 1.5 months, and here like the data for just 1 month. Let's not pull the plug too early. And what do you think? Are we ready? Are we really, really ready? Or like we just wait a couple of more weeks because we aligned to that? And here comes Houston, we have a problem. Metrics start to degrade. Still statistically significant uplift, by the way, on the business KPIs. So from analytics perspective, it's like, wow, interesting test. We will make a huge deep dive research. Funny one. Product manager is shocked and confused and thinking like, what? I wouldn't be promoted if the result is not as high. Business like, you meant we almost launched that? And so the decision to extend the test, because the effect seems unstable at that point, as an analytics team, we start a dedicated deep dive into the metrics and what's going on with this test. Do we have a bug? Do we have a problem? What's driving the drop? What changed under the hood? Then the final part, not for us, but for this A/B test, it becomes clearer. The effect is no longer meaningful. As an analyst, we got results from the research. From the start, it was a problem with some proxy metrics, but we haven't checked it from the beginning. We haven't prepared enough for this test. From product manager, he was thinking like, I'm dead. They're gonna fire me. Because he spent like 2 months testing, like 3 months testing, and we are not going to roll it out to the production. And for a business perspective, it was, that doesn't align with our vision and strategy. Why it happened? We need some like precise answers for that. So, and the decision is made. Stop the test. It's like the worst thing that could happen with this 3 months long test that was according to product strategy. But looking back, proxy metrics were flawed from the beginning. We could have noticed it earlier, definitely, but optimism and early uplift mask the issues for us. And let's quickly reflect on what we could have done better to make this test more successful. First of all, we should kick off a deep dive research to find a better proxy metrics for our North Star. And the goal is to identify more sensitive signals, metrics that react faster and can act like a guardrail during the test. That way, you will know earlier that things are going off track, even before the main metric reacts to the situation. Then we should focus on better alignment with business and prepare a solid A/B test design, definitely. In this case, we assume a potential wow effect, so we will need product expertise to estimate how long that effect usually lasts, or like some previous experience if you have it. We will design we would design the test with that in mind, and ideally agree in advance on a holdout strategy in case of success, if it would be like a solid, nice results during the first part of the test, not like degradation like we have. We'll also include like our sensitive proxy metrics to the guardrails, as we discussed before, and plan what to do if the certain metrics hit reference values and how we react if things go off track. So it should be all aligned before launching such an important test. And since we had clear scenarios defined from the start, we would spot the proxy metric issues earlier, pause the test on time, and move straight into planning the next iteration with the right changes. And it was like the main problem here. We wasted a lot of time and money, definitely, because we haven't delivered any other important features. It's not only that this feature went to the negative side, and it usually works like that. You have to prioritize what's going on in your business. You've got like not unlimited developer abilities. You've got some limitations. And so here I am to show you how to avoid the usual A/B testing traps. Here are some of the industry best practices that can help you run smarter, more reliable experiments. First of all, define core and proxy metrics pre-test. Before you launch, make sure everyone's aligned on what you're measuring and why you're doing that. It's the most important part. Validate sustainability. Run tests long enough to see if the impact actually sticks, not just spikes. Use advanced test methods, holdouts, phased rollouts, backtesting. Don't just ship and hope as we did. Build shared understanding in the product. Make sure analysts, product manager, business stakeholders all agree on what success really means in your company. And how do we actually do A/B testing right now? Is, I would say, the most nice part. Here's a simple pyramid of best practices that help turn testing from random trial and error into a strategic tool. Always start with a defined framework. Obviously, yes, definitely. Everybody doing that? I think no. So it's like about main questions. What are we testing? Why now? Why? How long will we run it? Without clear answers, it's too easy to shift the goals. So right now we have a strict practice of writing experiment briefs, where all details are aligned, double-checked, and agreed on before we launch. That helps avoid confusion later and keeps everyone on the same page from the day one, or day zero even. Ensure clear communication. Everyone from analyst to product manager to leadership should be aligned on what success looks like and how it will be measured. Be ruthless with metric selection. Not everything needs to be tracked. Focus on what actually moves the needle. It's a common analytics problem. We want to track everything. We want to track like millions of metrics and then couldn't be able to make the right decision out of it, because when you're tracking thousands of metrics, you're having false positive and results, and it's usually a problem. Use proxy metrics that actually work. Use proxy metrics with proven correlation. They would give you fast understanding that you're on or off track. And the last and the most important, in my opinion, make it strategic. A/B testing isn't just about numbers and techniques. The techniques is really important, by the way. It's about learning, long-term thinking, and building products that truly work. And at the end of the day, no fancy methodology or statistical model or something else will save a test that was poorly designed from the start. It's just the basics. It's the fundament that you're building your product on. The design of your A/B test, that's what truly determines whether you get an insight or an insight, or just pretty looking graphs. Yes, like using advanced techniques is important, is really important. But if your setup is biased, rushed, or overly simplified, even the best tools just won't help you. That's it. So, do you have any questions?
We definitely have virtual applause for you as well. Please drop them in the chat, and you can drop your questions for Ksenia in the chat as well. I can see virtual applause in the chat. That is good. So we have two questions from Alexei. I think we can start from them. The first question is, when you monitor main and proxy metrics, do you apply p-value corrections? That is the question from Alexei.
Can you repeat one more time, please?
Sure. When you monitor main and proxy metrics, do you apply p-value corrections?
Yes, we do apply, but it's still picking, and in classical statistics is not correct to use it, where do not use bias in statistics or anything like that. So, yep, it's a nice practice, but it doesn't fix it doesn't fix the whole situation.
Okay, so the second question is kind of follow up to the first one. Have you had experience using bias probabilistic approach in the case of limited experimental time? Yeah, you partly answered that, but you can elaborate on that.
Yeah, we definitely try to apply it in our business model. We make a lot of simulations like A/E testing to prove that Bayesian methods are not better for our business. I know that some companies are using that, but not in our case. We've got a lot of, I think it could be even their presentation of someone exploring why some pitfalls of using Bayesian methods, why it do not work like you're expecting to, and why it is better or worse in some situations to use it.
It seems that no silver bullets we found today. Yeah. Exactly. Okay. So we have, I think, 3 more questions. Let's start with this one. How to find a perfect testing period to balance sufficiency of data volume to handle, and deadlines from businesses. Do you usually use one standardized period, or you choose it specifically for each test? Well, it's about your flexibility, actually.
Yeah, usually in some old sustainable businesses, you kind of got some guidelines of how other analysts are running their A/B testing process, but usually it works like you calculate MD for their experiments, and the period itself kind of depends on how many users or how many user actions do you have. So you calculated it based on your data. So we have some standards for A/B testing because we're usually calculating the MD, and but we are recalculating and adjusting for each experiment. So our product managers know that the test at least would run for 2 weeks. It's not possible for us to run the test shorter if it is normal product test. But each time we're discussing and challenging ourselves, does it the right period of time, or should we adjust something? Because, for example, in such a huge test, when you're having wow effect, you just can't do that in 2 weeks. You're 100% sure that you would get the tricky results based on that.
Okay. So I think we have time for 2 more questions. Are you okay with that?
Yeah, of course.
Okay, cool. There is a question from Olga. Do you use reverse exps for very important features in order to check if everything is okay in long term.
Yeah, we are doing that. For example, right now we've got a feature that showed really nice results, but it was not, it was really peaking at the beginning, but then during like second month of testing, it went on the plateau. So we decided that we are ready, that like our business decided that it's ready to take the risks and roll out the feature to the production, because we got like huge audience and we're losing money because we're not delivering it. But from analytics perspective, we said that we could see some risks that the effect would decrease in the future. So yes, we're doing that. Kind of common one in our A/B testing process.
Okay, we have one more from Vitaly. How do you deal with data on users who sign off your product while the test is not completed yet?
How could you remember? Repeat
Yeah,
what?
sure. How do you deal with data on users who sign off your product while the test is not completed yet?
Oh yeah, we are, as if I understood correctly, I'm not 100% sure. We usually call it like churn during the testing process, and we track that really carefully because I'm from game dev, and one of the main metrics for us it's like activity and churn rate. We are really caring about these things. One of their goal is to increase the time in game and retention rate. So yeah, we're definitely tracking it a lot, and we're usually trying to get a bit more users in the testing process just to see how many of them actually stays with us. So yeah.
Okay, okay. So there is a last one in a minute. We've been taking questions from Ray again. Do you work with UX researchers for your role? If so, what does that look like?
Unfortunately, in Playrix, I do not work with UX researchers, but in some previous companies we did. And usually it was some cool researchers based on we're checking something from the data, we have a lot of hypotheses, and then UX designer just ask questions and we kind of trying to prove it with the data. It could work. I don't know. It's not related to the presentation, I think, or it's related somehow.
Okay, okay. So thank you so much. Do you have any maybe final thoughts to conclude your presentation with?
I would say that do a lot of A/B tests. It's nice practice, but be really careful of what are you really looking for. Make the nice designs and align with your business. It's the most important part. That's it.
Okay, that's very insightful. Thank you so much, Ksenia, for your speech. Let's give a bit more virtual applausing for the Ksenia. And I think we are ready to have our third, last but not least, speaker, our final speaker, Ivan Kitov, senior data scientist at Wolt. He's going to show us how to evaluate impact using the difference in differences methods, a powerful alternative when A/B testing, two previous speakers have been presenting about, is not possible. Ivan, let's confirm that you are audible. You here with us?
I am here. I hope you can hear me.
Yeah, I do. Let's check about the chat. Do you hear Ivan? Okay, yeah, I see. I see. Cool. So, Ivan, the floor is yours for the next 35 minutes. Yeah, let's give a virtual
Perfect.
applause to him.
Yeah, thank you so much. Let me just share my screen and I hope that everyone can see it. Right? Is everything working? Yeah, great.
I can see it. Let's wait a bit. It will appear on the screen of our participants in a second. Let's give it a bit of time. because you're still on the slide with your name. Yeah, let's wait for a couple of seconds. Sometimes some technical things are happening. Can we please show the audience, yes, the presentation of Ivan? Now it's finally here, and now you can start.
Wow. Right. Thank you so much, everyone who joined. And I'm not gonna take too much of your time with the first slide because actually it just summarizes what you've seen before that. So, in short, about me, who am I? I've been working for 10 years, roughly 10 years in data. Right now, I live in Berlin. I used to work at a bunch of different companies, big, small, Yandex, HelloFresh, some startups like Drops and Prisma Labs. And right now, I lead the analytics stream in Vault, and I analyze and evaluate the performance of career earnings, basically everything that's related to the money and what do the careers get at Vault. So, to the topic of presentation. What do we know about the data analysis? So what are the ways for us to analyze it? First, and the one that's most commonly used by everyone, it's the anecdotal data, anecdata. Basically anything that the product people come to you with, and it's not really reliable, but a good, solid first point for you to dive into. Second thing, the one that I'm gonna be talking about today is the observational studies, the diffs and divs, synthetic controls, or the causal inference overall topics. Basically, this is the next step from the anecdotes, so we're able to do some kind of research, and that is good for us. And then we can do, of course, the randomized control trials, the A/B tests, uh, the switchbacks, basically anything that gives us more statistical confidence. And on top of all, of course, the meta-analysis, which summarizes every finding that we have from all of these methods. Sorry. So, what are the use cases for the diffs and divs? Basically, it's the cases where random assignment is impossible. That is, for instance, the Uber's experimentation platform for pricing. You can't really change prices through A/B testing in any city. That's weird and not really like legally possible. Second thing is marketing campaigns. So one hyped example of this was the analysis of MTV 16 Pregnant, because it turned out that it increases the ratio of pregnancies for the teenagers. Unexpected, weird, but okay. And also the process improvements in operations, which is like the topic that's not really touched upon by the data analysts, data scientists in the online world, but actually you can do a lot of research in supermarkets or warehouses, the classical businesses, the staples of the offline businesses. And how does that actually come into your life? So imagine a case where you get this message. Yeah, first point is that of course it's vague. Of course you would like to be involved earlier in the process. But yeah, we also know that this should have been an experiment. We should have tried something before releasing it. But how would we approach this if we had the chance to do so? And that would be the diffs and divs. So actually the main idea about this is that it's just a simple step up from the simplistic before versus after. We want to compare changes rather than levels. Basically, we just try to get the impact of the signal rather than the noise around it. And we have the assumption that if the new feature had no impact, the treatment should have changed exactly, roughly the same as the control group. And we have one main assumption in order for this to be usable, and I think you could already guess it from the picture. It's the parallel trans assumption. So, which assumptions do we have here? So first things first is we shouldn't have any anticipation, and that is the case for any actually like for any data research that you are conducting. You shouldn't tell the user group that they would be in the experiment. Second thing is roughly the same as an AB. We want the groups to be roughly the same from with before and after periods, just because that's not the point of discussion. So we want the pre and post to be looking roughly the same from the user composition perspective. Of course, we shouldn't have any interference between groups because that will bring a lot of issues into the data, roughly the same as in AB. And the same definitions and measurement. That's the case where we don't want to interfere with the data, just like when you are training a machine learning model. You want to have your train and test data to be roughly the same, just like in machine learning. So basically, any anomaly such as COVID would break your analysis. And of course, the parallel trans assumption, the thing that we're going to be repeating a lot today. So the formal definition is what we want to do is to build a regression where the alpha is a set of fixed effects for the group that you are in. I think you can all read this from the screen. So the beta is actually the parameter that we are trying to get out of this, because the previous parameters, they are all coming from the external factors. We want to include them into the estimation, but the thing that will show us what's the difference between treated and control group, it's actually the beta parameter. And to the main topic of discussion, so how it looks in practice. What you want to do is to train the main regression and with the ordinary least squares methodology. Simple, think everyone has done it once, like just build a regression, see how it changes, and use the outcome multiplied by the treated as the variable that you're interested in. And it actually gives you the output like the is treated and post, and you can see here, of course, the data is all simulated, but you can see the impact that we are getting in here. And the arrow actually shows you the clustered errors that we are clustering the errors, that we're taking into account the external factors that might bring us some extra noise when we're doing this kind of research. So what would be the common issues that you might face here? First things first, of course, your parallel trans might be like failing you at times. And how would you mitigate this? Inspect your data before you do your research. That actually like will help you a lot. So the second thing is you would like to take into account the staggered adoption into account, because your diffs and divs, when they are like applied naively, you would see that the noise generated from the slow adoption, it adds you like a lot of noise, and you wouldn't see the impact, and you would probably underestimate the impact that you would be seeing. And the serial correlation standard errors actually the smart name for you for the errors that brought from the external factors, and you would like to cluster your errors just like we did in a previous slide, and you would probably like to add the time as a unit of measure into your regression, because time actually impacts a lot of things when you're building regressions. And the final thing is the autocorrelation. So you might want to model explicitly the time trends like seasonality and etc. Because usually, like whenever someone says things like seasonality, they just probably don't have a better explanation for this. But in this case, you might want to do the simulation of the time trends just to make sure that you do everything right. So in this case, we've added a bunch of issues. First thing is the slow adoption. As you might see here, the impact is increasing, and the unit-specific trends, we are taking into account the correlation here. And also, we've added the time component into the regression so we can see how it looks in the outcome. And basically, in here, you would see that the average treatment is actually greater than it was before, when we've only used the fixed timestamps for the beginning of the treatment. So, how it looks in the data now, in the code now. It gives you a lot of outputs because we've added an extra view for the time. And as you can see, as time increases, we get the change in impact in like before to the point of injection. And we've increased the complexity of the regression, where we take into account the relative time and the treatment. So we just want to know how many days has passed since you've introduced the treatment. And of course, the clusterization of errors, the thing that we've kept when comparing to the simple case. So what would you research further than the diffs and diffs? So the synthetic controls is it's one of the common things that used as an alternative for the diffs and diffs, but you would need a lot of attention to the detail when constructing the synthetic controls, and there is like a lot of arguments whether this is better or the diffs and diffs. So the other couple of things also come from the causal inference field, the propensity score matching and the double ML techniques. The pros and cons, basically, for the propensity score matching is that you will have to have a good enough estimator to predict the probability of being in a treatment. And that's also the case for the double ML. Basically, you create another issue for you. You are not only solving the analysis part, but you are also trying to build the good enough machine learning model for you to use. And the last thing is controversies. So I've mentioned previously the 16 pregnant research, and turns out that it was a little bit flawed. So the researchers didn't really state how they used, which kind of data they used, what were the components of the research, and there has been like three works surrounding this case. So they just had to present an extra evidence proving that the rate of teen pregnancies has increased, in fact. So basically, what they had to do is to show the time components that they've used, and they didn't do the simple pre versus post comparison. They also used the relative time compared to it. So what do we have to say in the last slide? So yeah, the diffs and diffs is a really powerful tool to analyze your data sets when you are not able to do the true experiment. And the diffs and diffs, while a powerful tool, but you will have to take into account a lot of things in order to make sure that everything is working properly. So you would always have to check your assumption. And if you haven't noticed, but yeah, you always have to cluster your errors because the different subgroups within your control and treatment, they might have their own trends, and you would also have to take them into account. And before using the diffs and diffs, one thing that you would always have to do is to know what kind of data you're using. I think that's actually a great advice for anyone who is doing data analysis and data science, is to know your data before jumping to conclusions. But in this case, it's really, really critical. So yeah, thank you so much for listening. And if you have any questions, feel free to shoot them.
I'll give you actual clap, Ivan. Thank you so much. And we are waiting for virtual claps as well. We already having questions in the chat, so I think we can go through them. So the first question is from Vlad. How do we account for confounders with the idea? How to be sure that the effect is not biased? That is the first question.
Yeah, so if you want to take into account the confounders, just include them into your regression. That's the fixed effects part of it that you are researching here. So going back a couple of slides. So the alpha G, it's the confounders that you would have to take into account. And one of the cases where you might see that diff and diff is not really applicable is that you might see that the effects of the confounders, they might be greater than your treatment effects, and that is
sorry,
the edge
Ivan,
case.
Sorry.
Yep.
I want to interrupt you and ask the technical team to bring our presentation back, if possible, because Ivan now is showing important things that are part of his presentation. Yeah, sorry, you can go ahead. I'm just...
Okay. Yeah, but I think I've answered like the question, but it might be more like obvious if I just show it through the presentation.
Okay. So we have, I think, a couple more questions. The second one is for an educational product where we have clustering by school. Do you have any recommendations for the case where there could be systematic differences between the clusters? The question from Lady.
Yeah, so diffs and diffs is applied through, it's like methodology that comes from the econometrics, and the difference in schools is one of the topics that's also covered like in the fundamental research. So when you are clustering by the school, it all depends on what kind of properties do you have in that describe your school. Because if you are just comparing a data point coming from school, I think that's not the best approach. You should be using the deeper level of granularity that kind of like shows you what kind of data do you have. So I would probably it would take a look at the data. So the first naive approach would be to take a look at your school trends overall. So if the data points, if your trends align and if you have any other properties, then it might be viable for you. But in practice, you might see that the difference won't be noticeable and you would have to go a level deeper.
Okay, I think it makes sense. We have two more questions. The first is from Mikhail. Can you please elaborate on what it means that price A/B tests are not allowed? Does it apply to any particular markets or in general for the whole company?
Yeah, so the price A/B tests are not allowed is in cases where, for instance, you have your so like that's actually like the practical constraints that some markets might have is that if you offer some kind of uh, job for like a taxi driver, they should have the same compensation for the same kind of tasks. And if they have, for instance, a contract with you, you cannot price them differently because that's kind of illegal. That's the first thing. Second thing is the network effects. So let's say we change the price for we try to run an A/B test. So or then we might even do this through a switchback. But the network effects, they get pronounced not only on a single point, but they also distributed between the other points in your data set. So it would be safer for you to run the pricing experimentation in two different cities where the data sets don't overlap, so they are not trickling through. So there's no like data leakage in your control and tests.
Okay, I think we have last question from Vitaly. How do you differentiate between noise and divergent, though real and significant behavior of users for your tests?
Yes. So the good thing is that the diffs and diffs provides you the p-values. So when you are building the regression, and yeah, basically, if you take a look at the outputs of the ordinary least squares regression, every coefficient there has the p-value and the confidence interval. So that gives you a solid idea of what's your impact. And often you might see that there is like some positive effect, just like in any A/B test, but the p-value doesn't give you enough like confidence in what's going on. So the main benefit, and I forgot actually to mention that in my presentation, is that you get your statistical values out of the diffs and diffs. So it's not only like one number, which is your impact, but it's a bunch of numbers that you get out of any statistical tool, like p-value, your confidence interval, and etc.
It makes sense. I think we've covered everything that was in the chats. Yes, I think so. Ivan, thank you so much. Do you have any finalizing remarks for an audience?
Yeah. So the main idea is that whenever someone comes to you with questions, how did we do, and we haven't run A/B tests, I think the main insight that you get out of this presentation is that yeah, you can provide them some statistical ideas. There's a bunch of them, and we've only covered just one, and there's multitudes of ways how you can approach this.
Thank you so much. I think it is really insightful. And I think that's it. Thank you, Ivan. It was very nice to have you here. And I think that wraps up our data analytics meetup. I think we are coming to an end right now. I want to say huge thanks to our speakers, Ivan, Ksenia, and Nikolai, and to all of you for being part of today's session. I think all of us uh, need some virtual claps for the end. I think you all deserve it. We hope you are walking away with ideas to test, to rethink, to explore. I do think it was very useful for all of us. Important thing that we will be sending a follow-up with slides and recordings. I saw the questions in the chat about it, so don't afraid. We will send it to you. Keep an eye on your inbox. And if you want to hear about our future events, be sure to connect with us on LinkedIn. We will drop a link on our LinkedIn in the chat in a second. It's already there. You can click and connect with us. And hope you had a great evening. And I hope you will have a great rest of evening. So see you next time. And thank you for being with us today on our analytics meetup. Have a nice day.